Here's a quick video on all the differentiation rules, and I hope this is the only video you'll ever need to learn differentiation rules. Number one, we have the power rule. The power rule says that when you have a function x to a certain power n, what you can do is you move the power n to the front and subtract the power by 1 in the exponent. Let's say you have x cubed and you wanted to differentiate x cubed. What you'll do is you will move the power to the front, which is 3, and you'll do x3 minus 1. In this case, we have 3x squared. Now, how would you go about solving x to the 1/2? You would do the exact same thing. You would move down the 1/2, and then you would do x to the 1/2 minus 1 power. This is going to give you 1/2 x to the negative 1/2. Now, how would you solve this one? 1 over x squared. We can still use the power rule, but let's change this into an equivalent but different form. Okay, so we're going to need to use our exponent rules to solve this. We know that if we have a power on the bottom, what we can do is bring it back to the top and make it negative. This is going to be a lot easier to use for the power rule. All right, now that we've changed it to a different but equivalent form, we can now do 1 over x squared a lot easier by calling it x to the negative 2. We can now take the negative 2, bring it down, multiply by x to the negative 2 minus 1 power. That's going to give us negative 2 x to the negative 3. Here are some important simple derivatives that you should have memorized. The first one is if k is a constant, the derivative of a constant is always a big fat 0. Secondly are our trig derivatives. The derivative of sine of x is its buddy cosine of x. And the derivative of cosine of x is negative sine of x. So they're opposites, but when going from cosine back to sine, you have a negative. The derivative of tangent of x is equal to secant squared of x. The derivative of secant of x is equal to tangent of x times secant of x. The derivative of cotangent of x is equal to negative cosecant squared of x. And the derivative of cosecant is equal to negative cotangent of x cosecant x. The derivative of natural log is 1 over x. And lastly, the derivative of e to the x stays itself. It's just e to the x. Here's a couple things that might help you memorize the trig functions. One of them is that if you're ever deriving something with a c at the front of its name, cosine, cotangent, or cosecant, what you're going to see every single time is that its derivative is going to start with a negative sign. In cosine's case, it's going to be negative sine of x. In cotangent's case, it's going to be negative cosecant squared of x. In cosecant's case, we're going to get negative cotangent x, cosecant x. Another thing you should look at is the difference between a cotangent and just the tangent. They end up having the same derivative, but outside of a negative, the only difference is that there's a co at the beginning of all the words in it. We have negative cosecant squared of x, negative cosecant squared of x, and this one is a positive secant squared of x. Cosecant, secant, cotangent, tangent. Because there's a c at the beginning, we make sure that there's a negative. And then because there's a the co stays here. And because there's no co, it's just tangent, we don't put a co at the beginning, it's just secant. We get that exact same thing with cosecant versus secant. What we get for cosecant is obviously a negative because there's a c at the beginning. And then we're going to get cotangent times cosecant. The only difference is one, because there's no c there, this is going to start out positive, not negative. And secondly, instead of cotangent, we're going to get only tangent. And instead of it being cosecant, we're only going to get secant. So depending on if you're starting with the co or if you're starting with no co, will change if there's going to be a negative, and if you're working with cotangent, cosecant, or if you're working with tangent and secant. All right, moving along in our differentiation rules, we first did power rule. The second one we're doing is product rule. In this case, if you have two functions that you can split apart separately, what we can do is, to find the derivative of their product, we can take the derivative of the first times just the second function. And then you're going to take the derivative of the second times just the first function. All right, let's go ahead and try and find the derivative of the sine of x times x squared. Well, the derivative of the first, which is sine of x, we know is cosine of x. That is the derivative of the first. For our second function, x squared, we keep it alone for the first one. So we just multiply by x squared. And then we add the derivative of x squared, which is 2x, based on our power rule. And then we take sine x and leave it alone. So our derivative is cosine of x, which is the derivative of sine of x, times x squared, which is just our original function. And then we have the derivative of x squared, which is 2x, and then we have sine of x. Let's go ahead and do one more. We have cotangent x times natural log of x. I'll make cotangent my first function and natural log my second function. And what we're going to get is the derivative of the first, which in this case is negative cosecant squared x, times the second function, which is the natural log of x. And then we're going to get plus the derivative of the second function, which we know the natural log's derivative is 1 over x, times the original first, which is cotangent x. We can go ahead and simplify this real quick, saying that this is cotangent of x over x. All right, next up we have the chain rule. Now, what is the chain rule? The chain rule is a situation where you have this function, and inside the function as the input is stuck another function. And what we do is we take the derivative of the entire function with the input inside, and then you multiply by the chain, which is the derivative of the input or the inside function. I sometimes think of it as like nesting dolls. You take the derivative of the outside one most first, and then you go inwards and take the derivative of the inside functions. All right, let's go ahead and solve this derivative, the natural log of x squared. Well, I'm already seeing that this is our outside function and our inside function is x squared. So what we're going to do is we have to take the derivative of the outside function first, with our input being this inside function. All right, so our input stays the same, but the derivative of the natural log is 1 over x. But because we have an x squared inside, we make it x squared. Then we multiply by the derivative of the inside function. And what we're going to get is 2x 2 minus 1 because of our power rule. And we can simplify this by just making this 1. All right, simplifying this even more, what we see is we have an x on top and an x squared on the bottom. What we can do is we can cancel out an x on the top and cancel out an x on the bottom. This is going to give us a final answer of 2x. Let's do another one where we have the derivative of sine to the x e to the x, and highlighted in green is our outside function, and our input function is e to the x. We can use the chain rule. So the derivative of the first one is going to be cosine, and the input is e to the x, times the derivative of the input function, which is just e to the x. Our last rule that we're going to be doing in this video is the quotient rule. This time, instead of having two functions being multiplied to each other, we have a function being the numerator, and we have another function being the denominator. And if we have these two functions and a fraction where one of the functions is the numerator and another function is the denominator, we can write the derivative like this. The derivative of the first times the original second minus the derivative of the bottom, the denominator function, times the first by itself, all over the denominator squared. So we have the derivative of the numerator times the denominator. And because there's a subtraction sign, we need to make sure that the first term stays the derivative of the numerator and the denominator. Do not mistake these two terms and flip them. In the second term, we need the derivative of the denominator times the numerator all over the denominator squared. All right, let's go ahead and try and find the derivative of x natural log of x. Remember, we need this function to be our numerator function, and this function will be our denominator function. All right, here we go. The derivative of x using our power rule, we bring down the 1 and then subtract by 1 in the top. This is going to give us 1x to the 0. It's just equal to 1. So the derivative of x is 1 times the natural log of x minus the derivative of the natural log of x, which is 1 over x, times our original numerator, which is just x. And all of this is going to be the natural log of x squared. The natural log of x times 1 is just going to be natural log of x. And this 1 over x times x, we can make that equal to 1. This is our final answer. Let's go ahead and solve this other one. 3e to the x over cosine of x. Well, we can label this our numerator function and label this our denominator function and use the quotient rule. The derivative of the top is just 3e to the x because e to the x stays the same. Then we multiply by the denominator, which is cosine of x. Then we subtract the derivative of the denominator, which is negative sine of x, times the top, which is 3e to the x. And then we're going to take this whole thing and divide it by cosine of x squared. Now what we could do is we can actually factor out 3e to the x. And then we're going to get cosine of x. And because we have this minus minus, we can just make them a positive. All over cosine of x squared. And there we go. There are our derivative rules. We have power rule, product rule, chain rule, and quotient rule, and we've gone through exercises for all 4 of them. In the next video, I'll do a bunch of practice problems to work out these 4 rules and apply them together.